right, so welcome to MAT 205. We're in week 7. Let's take a look at our topics for the week. Oh, Lordy, we've got lots of topics. So it looks like we're looking at ranges of data sets, looking at center and variation, doing population and sampling or sample standard deviation. We're going to be looking at percentage of data below specified values, calculating percentiles, interpreting those, making a box and whisker with our 5-number summary, looking at a graph of distributions to find probabilities, and then digging into the empirical rule. We're also going to add in some z-score calculations. Just for giggles. Okay, let's get going. First up, we're going to look at how do we find the range of a data set. What is the range of a data set? So the range is a measure of how much the data is spread out. So it's one way to measure kind of dispersion of data. The range is a good indicator of how spread out the data values are. How do you calculate the range? Well, you take your greatest number and you subtract out your least number. So it's max number minus minimum number. Find the range of this data set. So I'd like you to pause the video and find the range of this data set. Okay, if you're back, the first thing that you should hopefully have done, and maybe you didn't, maybe you skipped this step, and that's okay, is I put these in order from least to greatest. So 76, 78. So I'm going to put these in order. An Excel spreadsheet would be great for helping us with sorting. But I didn't use an Excel spreadsheet. I just kind of went through and made sure 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, made sure I had all my data values. So I'm going to take my max number and my min number, and I'm going to subtract them. So 93 minus 76 is going to leave us 17. So 17 is the range of data between 76 and 93. You're going to find a range of 17. So 17 numbers. The distance is 17 between the minimum and the max. Oh, okay, hopefully that'll help you when you're calculating ranges of your data sets. Okay, let's compare the measures of center and variation. The range is a measure of how much data is spread out. We just calculated that. The range is a good indicator of how spread out the data values can be. Here's what we need to remember. A small range indicates low variability in the data. A large range indicates high variability in the data. Let's take a peek. How can we test this out? The test scores of students in 4 classes are summarized below. So we have the range. I guess they calculated the range of the scores. Range is 25, 29, 31, and 32. Based on the information above, which class's score had the most variability? And based on the information above, which class's score had the least variability? Okay, so remember to go back for a little cheater sheet here. Remember, a small range indicates low variability and a large range indicates high variability. Okay, so if hopefully you pause the video and you're back, which class's score has the most variability? We're going to go with class D, hopefully you figured that out, because it has the largest range. It's the largest range. All right, so that takes class D out as having the largest range. And then based on the information, which class's score had the least variability? Well, hopefully you pinpointed class A. It's the least variability. Right? So once again, if you need to always go back to a little cheater sheet. Smaller the range, low variability. This had the smallest range, has the least amount of variability. A large range has the highest variability. This was the largest range, so that won the prize for having the largest range and therefore giving us the highest variability in our data. All right, let's move on. Okay, what do we know about the mean? We remember that the mean is a measure of center and it can indicate how low or high the values in your data set are on average. Here's our cheater sheet for the mean. When the mean is small, it indicates the values in the data set are low on average. When the mean is large, it indicates that the values in the data set are high on average. All right, so we're going to keep this cheater sheet close to us as we look at an example problem. Okay, test scores of students in 4 classes are summarized below. We've got class A having a mean of 109, class B mean of 106, class C mean of 114, class D mean of 105. Based on the information above, which class's score had the highest scores on average? Based on the information above, which class's score had the lowest scores on average? So please pause the video and answer these questions and check back. So if you're back, hopefully for this first one here, based on the information above, which class's score had the highest scores on average, hopefully you picked class C. Class C had the largest mean. It had the largest mean. So it indicates that on average in that data set for those students in that class, they scored higher. Then we have to figure out which class's score has the lowest, and that was going to be class D. So class D has the lowest scores on average because the mean is the smallest. Mean is the smallest. Okay, hopefully that was helpful. We're going to move on. Okay, we've now moved into standard deviation taken from a sample. What is deviation? Deviate is a measure of the spread of the data from their average or their mean. The more the measurements tend to differ or deviate from their mean, the greater the standard deviation. Okay, so I have a little website here which helps you if you'd like to take a peek at that with standard deviation. Here is standard deviation formula from a sample. So it looks kind of scary, but let's break it down because it's really not. We're going to do this in steps. So our S here just stands for standard deviation from a sample. So I kind of like it that they use S because S refers to standard deviation from a sample. How do you find standard deviation? Well, you're going to work this formula. Let's work inside of it first. So this little X is your individual raw score that you'll take from your data. This is X bar. So this right here is called X bar. That's the average in a sample. Great. That's the sample mean. We're going to, looks like, subtract our individual scores from our mean, and then we're going to square it. We have a Greek symbol here, E. That just means to sum up. To sum up. Below, we have the number of observations in our data set, -1. All right, so let's see if we can work an example out here. Let's do one together. Below are times and days taken for a sample of 5 customers from Lamar's computer store to pay their bills. I guess it's the number of days it takes for them to pay their bills to Lamar. Find the sample standard deviation of times and round your answer to 2 decimal places. Okay, this is going to take a little bit of work, so just have some patience. Hopefully you got some caffeine and some chocolate around here. We're going to go for it. So the first thing we're going to do is we're going to calculate X bar. We need to figure out what X bar is. So we're going to find X bar, which is also just the mean, and we know how to do that. So we have 14 plus 30 plus 44 plus 34 plus 33. We're going to add those up and divide by 5. So if you want to pause it, come back and check in. All right, so if you're back, hopefully you got that your mean is 155/5, which basically is going to be 31. That is our X bar. So if we look at all these numbers, the number of days it takes for customers to pay their bill, on average, it takes them about 31 days. Looks like some people paid in 2 weeks, some people took a little more than a month, but on average, 31 days. 2, we need to take care of this next piece of the formula. So let's show that again. We're going to take each of your data values and subtract away the X bar that we just found. So we're going to subtract the mean. We're going to subtract the mean from each data value. All right, so I kind of do a little chart like this. So I got each of my data values I'm going to put down here. And I'm going to, those are my data values, these are my X's. And I'm going to subtract away my X bar, which we know is 31. We're going to get those answers. All right, so pause the video, do the subtractions, and see if you can meet back with me here in a minute. Okay, so if you're back, hopefully you got -17, -1, 13, 3, and 2. So this was just subtracting the mean. We're going to take that away from each of the data points. We're looking to see how far did they get away from that average. So we have a whole bunch of different differences here. So these are all the differences. Now, if we go back to our formula, we've taken care of X minus X bar, right? But now we're going to, for working inside our parentheses, like please excuse my dear Aunt Sally, we need to square this. So we're going to square each of these differences. So that's step 3. We're going to square each of the differences. Now I want you to be very careful on this point here. All right, so -17 squared, -1 squared, 13 squared, 3 squared, 2 squared. All right, each one of these should come out to be a positive number because -17 times -17 is 289 plus -1 times -1 is 1. 13 times 13 is 169. 3 times 3 is 9. 2 times 2 is 4. Okay, so why am I putting addition signs in between each of the squares of these differences? It's because we need to sum up. We're going to do this summing up of our differences between our data value and our mean squared. So this is what's happening up here. So we're going to add up all of those differences. So if I add these up, then please check me. So pause the video and go behind the scenes and all right, I'm getting 472. Okay. So that's step 4. Okay. So now we have the numerator here, it's 472. In the denominator, it says n-1 number of observations or values in the data set -1. Well, so for step number 5, we are going to divide by the total number of numbers in the data set, but -1. Okay, so 5 minus 1 equals 4. Okay, so let me write out this formula just a little bit here that might help us. Just need a little more room. Okay. So let me show you where we are in the formula because this can be very confusing if this is the first time you've done this. We have standard deviation is equal to the sum of x minus x bar squared over top of n-1. Okay, we have already figured out what the sum of x minus x bar squared is. We know that is, I should say 472. We have to go with 475, but it's 472. Lo siento mucho, that is my mistake there. So we figured out what that is. So the square of the standard deviation is equal to the square root of the sum of this, which is 472, divided by n minus 1, which n minus 1 is equal to 4. Okay, so we're going to take 472 divided by 4, and then take the square root. So that's going to be step 6. Go ahead and write that out. Step 6. We're going to divide 472 by 4, then take the square root. That square root happens at the very end. Okay. So 472 divided by 4 is 118. And if we take the square root of 118, and I think they want us to round to 2 decimal places, we're going to get, there's a glare there, roughly, see if I can make this a little clearer, roughly 10.86 is our standard deviation. Okay, what did we just find? All right, this took a lot of time to find our standard deviation. Let's go back to the original problem. So these are the times and days of 5 customers that it took for them to pay their bills. We found out that the average was 31 days. So we found out the average for them to pay their bill is 31 days. And this tends to deviate, that's what standard deviation, approximately 10.86 days. Okay, so it deviates. And you can kind of see it's not exactly, the average is 31, but there's a spread. We already know that. We can calculate the range if we want. That's one way we can also find how far the data varies from the mean, but we could find this deviation. So approximately 10.86 days. Okay, I think we might need to try that again. All right, we are going to again work through standard deviation from a sample, which is a different set of data. Here are the shopping times in minutes for a sample of 5 shoppers at Walmart. Find the standard deviation of this sample of shopping times. Round your answer to 2 decimal places. All right, these are shopping times as these people are rolling around Walmart. Okay, so step 1, if you recall from our first example, was to find X bar. So I want you to try this step on your own. So pause the video. All right, so step 1, if you're back, hopefully you found that the shopping time is on average 29 minutes. Okay, that's our X bar. That was step 1. All right, go for step 2. If you, I know you probably maybe not remember that, but go back to your notes and remember we're going to be we're going to take each of our data values and subtract away our mean. That's what we're going to do next. So take a minute, pause the video, give that a whirl. Okay, so if you're back, hopefully you found those differences. Remember, we're looking at how far away data values deviate from the mean. So this is part of why we take each of those data values and subtract away the mean. We're looking to see how far they vary. And then we need to square these, and that's so we can standardize. So we're going to square. So 2 squared is 4 squared plus -5 squared. All right, and I'm kind of combining, let's go back. We squared each of the differences in the last problem, and then we add them together. So I'm combining kind of step 3 and step 4 together. Okay, now remember that formula. Once you just sum up all of the differences that we just found that have been squared. So we need to sum this up. So if I add that up, I'm gonna get to 130. Okay, so in our formula, we are down to standard deviation, oopsie, off the charts, is equal to x minus x bar squared, the sum over n minus 1. So we have already calculated that top piece. We've got 130 is the sum of all of those differences from how far away each of those pieces of data vary from the mean, and we standardized it by squaring. So we've got the sum of 130, and the n, well, we have 5 data points. 5 minus 1 is equal to 4. So now we are in the zone here. We're going to get our calculator. You're going to divide first. 130 divided by 4. 30 divided by 4. And the standard deviation is going to be equal to the square root of 32.5. So don't forget to take your square root of 32.5. And let's see here. You're going to want to round to 2 decimal places. So we're going to go 5.7. Okay. The standard deviation is approximately 5.70 minutes. Okay, so what did we find? We found that these are the shopping times of 5 customers at Walmart. On average, 29 minutes to shop. Give or take, standard deviation of 5 minutes. This is how far these data values tend to vary on average from our average. Okay, that's going to be it for this video, because when we come back, we have done a couple practice problems of calculating standard deviation from a sample, but we're going to now also learn how to calculate standard deviation from a population. So I'll see you back in the next video.